Hello everyone, welcome to Modern Analytics Academy. We are a group of Microsoft Cloud Solution Architects focused on analytics and AI. There are 5 sessions in Modern Data Analytics Academy series, including acquisition and storage, data modeling, data pipeline, security and governance, and lastly, visualization. This session is focusing on data pipeline, and if you are interested in other sessions, you can go to aka.ms/MAA short link, and you can find other sessions and related materials. Today, we will focus on what is data pipeline, and then we'll move into 4 services on Microsoft Cloud. Each of them, towards the end of each of the sessions, I will show a quick demo of how those services look like. So first of all, let's start with the definition of what is data pipeline is and share some key concepts in data pipeline. So data pipeline stands for, also known as data integration. It helps move data from one or multiple sources to another sources so that it can be stored, used, for analytics or combined with other data. More than ever, enterprises are placing a high priority on data integration, especially to support analytics and business intelligence initiatives. According to a survey by Forbes, there are 80% of enterprise business operations leaders says data integration is critical to ongoing operations. 67% of them rely on data integration to support the analytics and BI platform today, and 24% plans to move to it in 12 months. 65% of organizations prefer cloud platforms or hybrid cloud integration solutions because of its flexibility as well as innovations and lower total cost of operation. There are some key concepts in data pipeline. So first of all is source and destination, which is the location of your data and the direction it goes. Data connections are defined how your data pipeline services is linking to your source and destination. It includes data paths, data type, authentication method, etc. ETL or ELT, which E stands for extract, T stands for transformation, and L stands for load. It's the process of how you move your data. So each activity stands for a step of your ETL process. So pipeline is a logical group of activities to accomplish a higher level goal. Triggers decides when you want your data pipeline to run. Orchestration is the entire process, allows the automation of data-driven process from end to end. There are many services on Azure or Microsoft Cloud supports data pipeline functionality. We selected 4 of them today to show you different functionality it supports. And let's start with Azure Data Factory first. So Data Factory is a solution which can allow you to integrate all your data, especially when combined with other Azure technologies. Data Factory is a fully managed, serverless data integration service that is easy to use, cost-effective, powerful, and intelligent. You can easily construct ETL and ELT process with code-free method, and you can also write your own code. You can visually integrate data source with over 90 plus built-in connectors with no additional cost. Then you can deliver integrated data to your data serving layer to unlock limitless insights. Here is a data factory overview. First of all, its audience are for data engineers, data scientists, citizen integrators. You can source data from multiple sources, including on-premise data source, multi-cloud data source, SaaS-based data source, through its connectors with 90 plus built-in connectors. You can prepare, transform, predict, and enrich data using code-free or code-centric method, which we will go into more detail later. Finally, you can serve to any destination you want in this example, there is a Azure Synapse data pool, SQL pool. And also, through Azure Data Factory Studio, you can monitor and orchestrate the entire data factory pipeline. So with Azure Data Factory, as I mentioned, there are 90 plus built-in connectors. Those connectors, you can ingest, with those connectors, you can ingest data from multi-cloud sources such as AWS and Google, on-premise sources such as Teradata and Oracle, as well as all the Azure data services such as Cosmos DB, Azure SQL DB, as well as SaaS apps such as Salesforce and Marketo. You can have the full capacity of up to 5 GB per second throughput network bandwidth behind you. So with all these connectors, Data Factory is a powerful and unified data integration solution that powers your operational database, machine learning, BI and analytics, and app modernization. Integration runtime is the compute environment within Azure Data Factory. There are 3 versions of it. First of all is self-service hosted integration runtime, which allows you to orchestrate data movement activities between on-premise environment to cloud. The default Azure integration runtime supports data movement and activities in Azure Public Network, Azure Managed VNet, or Azure Private Endpoint. The special type of integration runtime, SSIS integration runtime, supports SSIS package run on Azure. So within Data Factory, you can choose to work on code-free or code-centric data transformation. With mapping data flow, it is a code-free version of data transformation. You can do a visually designed data transformation in Data Factory without writing any code. The data flow activities can be engaged via existing Data Factory scheduling, control, flow, and monitoring capabilities. So with the code-free data transformation method, you can handle all the code translation, path optimization, and execution of your data flow jobs, so that you can spend less time on designing, testing, and maintenance, while focusing on business logic. There's another type of code-free transformation method is called wrangling data flow. Now is renamed to Power Query. It's the similar experience as you see in Power BI Power Query module. It is like Excel-like, and you can apply transformation steps and you can easily to see the already applied transformation steps or go back to the transformation steps. You can choose button click way of transformation tasks, for example, pivot, splitting column, join tables. You can create, debug, schedule, and monitor the randomly data flow in Azure Data Factory also. Of course, if you prefer to handle the data transformation in your existing code, for example, store procedure, for example, Azure Databricks notebooks, you can do so, because Data Factory comes with 6 easily integrated external computer engine, like Azure Data Factory, Databricks, Azure Functions, Azure Batch, machine learning services, and more. Shoot, too quick. So, as I mentioned, Azure Data Factory, it can orchestrate your entire runs at a scale. Orchestration part including the trigger. You can define triggers on demand, on schedule, on data window, or by events. And then those triggers can be linked to, attached to a pipeline, which can then is a logical group of activities. The pipeline itself can also trigger other pipelines if you prefer. With linked services, which is a computer engine, you can allow to support the on-premise or cloud-based data integration through self-hosted integration runtime or Azure integration runtime. Of course, you can monitor the data pipeline run, activity run, the performance of your computer engine in the Azure Data Factory Studio itself or through Azure Monitor with other Azure services. And you can also store the diagnostic, logging, matrix, and alerts, and events. Another very distinguished features of Azure Data Factory is supporting one-to-one easy-to-click SSIS migration. So to modernize your SSIS packages and solutions, you can lower the total cost of operation significantly, up to 88%. And Azure Data Factory make it so easy for you to migrate your on-premise SSIS packages to cloud through the integration runtime. Lastly, the Git integration allows you to achieve change management, source control, or CI/CD goals. Cool. I would love to do a quick demo of Azure Data Factory for you so that you can see how to start and what it looks like. So when you go to Azure portal, and you can create a new sources and by typing in Data Factory. Once you set up the Data Factory source and open it up, you can see it that looks like it. You can set monitoring, see the matrix here. You can set activity log, access control in the Azure portal. But when you're authoring the specific pipelines, jobs, and triggers, you should go to Azure Data Factory Studio if you prefer UI portal. And once you click the Azure Data Studio, you can find out it's landing in the home page, looks like this. And then on the left side, there's some components on the left side. In the center, you can see a lot of easy to start components, especially the pipeline template, where I like the most. is you can see a lot of reusable patterns to apply to your own case. On the authoring side is where you author the pipelines, the data sets, the data flow, and Power Query, and reuse the templates. I would love to start with data sets. Data sets is the definition of your source or destination. Data sets usually has a one-to-one relationship to many-to-one relationship to linked services. Linked services is on the Manage tab, defines where your data, what type of the data source is, and what's the path, the authentication method, as I mentioned before. And then the data set itself defines the specific file path for your source and destination. Once you have a data set, you can then use it in data pipeline. So for example, I have some existing data pipeline, and within data pipeline, there are some activities. In this modern data warehouse migration pipeline, I'm moving data from a storage account source, actually on-premise data, SQL data source, to the Azure data store as a CT table, and I can copy the data from storage to SQL DB, and I can trigger store procedures, and I can then archive data using another copy activity. Also, I have another data pipeline for migrating data from Azure SQL DB to Postgres DB, on-premise file to storage, etc. And you can apply activity by just drag the activities into your data pipeline and link it to it, so that you can change the logic. You can debug the data pipeline, click on debug, so it will run right after you debug, and you can see the result. And you can do transformation, as I mentioned. First of all is the code-free transformation for using data flows. So for example, this one is data flow ingestion to perform a join transformation with the two tables. You can do transformation with like graphic UI looks, and you can perform transformation without writing any code, like this. And with another transformation is Power Query, also known as wrangling data flow. Really, this is again similar to Power BI, Power Query, and is Excel looked UI. You can apply transformation steps, and you can change transformation steps on it. You can do transformation like this by right click or click the transformation tab on the top and to perform transformation. Also, you can go back to pipeline and add an activity to attach code first transformation, like I had here, which is a store procedure linked to a store procedure within my Synapse Analytics SQL pool. I also can link the transformation to Azure Databricks notebooks or HD Insight Hive jobs or machine learning batch jobs, etc. On the monitoring tab, you can see the pipeline runs, trigger runs performance. You can go to see integration runtime status and performance. You can set alerts and the matrix. On the Manage tab, again, I showed you before where you can define the linked services, define the integration runtime, add the integration runtime. You can set up Azure Purview, which is the data governance services we have, which if you want to learn more about data governance, we have another sessions in the Modern Analytics Academy you can refer to. You can also set a Git configuration. For example, I have my Azure Data Factory, these Azure Data Factory services linked to my GitHub repo, and you can do branch, create a new branch, do pull request, and you can also export your data pipelines into as an ARM template as for reuse purposes, and you can import other ARM templates. And you can set triggers for your pipeline runs based on schedule, on company window. For example, every 15 minutes, every 15 hours, every 1 hour, 1 day, etc. You can base on triggers based on storage events. For example, a new file was copied to a storage account. Based on that event, it can trigger underneath a pipeline. You can do custom events. Yeah. Also, you can set the security and the credentials on Studio itself. I usually go to Azure portal to set access control, and come here for manage the keys and the credentials. So that concludes the Azure Data Factory demo. Let's move to another services. It's called Synapse Analytics. Specifically, we're focusing on data pipeline module of Synapse. So first of all, let's level set of what is Azure Synapse Analytics. Synapse Analytics was a rebranded name from Azure Data Warehouse, but it's not just a data warehousing services. It is a platform for all your enterprise analytics need, including Synapse SQL, which allows you to do distributed query systems that enables enterprise to implement data warehousing and data visualization scenarios using standard T-SQL experience, which are familiar to data engineers. It also offers both serverless and provisioned resource models. With the Spark Pool, Apache Spark Pool for Synapse, you can do deeply and seamlessly integration with Apache Spark, which is the most popular open source big data engine used for data preparation, data engineering, ETL, and machine learning. ETL is a simplified resource model, free you from having to worry about managing clusters, while allowing faster Spark startup and aggregation auto-scaling. Synapse pipeline is what we are focusing today. Comes built-in in the Synapse workspace, which allows you to have the same experience which you had in Azure Data Factory, which we just mentioned allows to have so much functionality, allows you to migrate, integrate, enrich the data from multiple sources to the destination. Synapse Studio is the web-native experience that ties everything together, and which you can allow data engineers, data scientists, data integrator, BI developers all in one place to manage the entire analytics solutions, all in one location. So data pipeline in Synapse, as I mentioned in the previous slide, is share the same code base as Azure Data Factory. There are just two features which is not supported in data pipeline, which first one is the SSIS integration runtime, which is not there in Synapse pipeline. Also, there is no Power Query aka regular data flow in Synapse yet. So I would love to do a quick demo of Synapse Analytics, especially the pipeline piece. So I'm going to, again, similar experience as you are set up a resource in Azure portal. You just type in Synapse, and then you can add a new resource to your resource group. And once the resource is set up, it's really similar to Azure Data Factory resource. And there is a button for you to click for open the Synapse Studio. And if you go to landing into Synapse Studio, again, it's really similar UI to Data Factory Studio. In the homepage, it's a lot of easy to start resource and the templates. And the difference here now exists in, again, Synapse is where you can do SQL data warehousing, and there is a data tab allows you to see the how SQL serverless, dedicated SQL pool, your linked services to storage account, Cosmos DB, or data integrated data sets. You can connect it to external data or add a new SQL database or data hub base. With the develop tab is where you can see all the pre-stored SQL scripts, right? And you can also find out your Spark notebooks if you are using Spark pool. And where the data flow is also showing in the Azure Data Factory is under the development tab. You can define mapping data flow here, like you can do in Data Factory. The integration tab hosts the pipelines. You can add new pipelines. You can, in the pipeline UI is just the same thing as Azure Data Factory. You can add copy data activities, transformation activities. You can add the native Synapse activities here. As you can see, very similar to your Azure Data Factory experience. The monitoring tab is similar to you can see the integration runtime, integration pipeline run, trigger run. You can also see the performance of your different SQL pools, Apache pools, Data Explorer pools, and you can monitor the activities. Also, on the Manager tab, besides the integration, security, Git source control, you can also find manage the different analytics pools, SQL pools, Spark pools, and external connections. Cool. That's the quick demo of Synapse. So you may be wondering, so since Synapse Data Pipeline shares the same code base as Azure Data Factory, so which one I recommend? So if you want to build in your entire analytics workload in Azure, and you have not used any other services before, or you just use a small portion of the data analytics solution into Azure, you can choose to start with Synapse as a greenfield analytics solution. If you already have used Azure Data Factory, and you can choose to stay there, or you can choose to migrate. And if you have, for example, you need Azure to migrate you need Azure to host your SSIS packages, you would need to use Azure Data Factory. So next services, let's talk about the Power BI data flow. Data flow in Power BI is basically a self-service data integration tool available in the Power BI services that can be used to fetch data from various data sources and create a data model on the cloud based on the schema of the datasets. So data is stored as entity in the common data model in Azure Data Lake Gen 2, Storage Gen 2. Data flow are created and managed in app workspace using the Power BI services. So Power BI introduced data flow to helping organizations to unify the data from disparate sources and prepare it for modeling. Data flow are used to ingest, transform, integrate, and enrich big data by defining data sources, connections, ETL logics, refresh schedules, and more. In addition, the new model-driven calculation engine that's part of data flow makes the process of data preparation more manageable, more deterministic, and less cumbersome for data analysts and report creators alike. Data flow are designed to use the common data model, a standardized, modular, extensible collection of data schema published by Microsoft that are designed to make it easier for you to build, use, and analyze data. As I mentioned, the common data model, which really extended the capabilities of the data entities. Right now, if you want to provide the customer with a great ready-to-made insight in the product and enable unconstrained self-service customization, it is hard to manage all this together. With the common data model, it helps with people to manage data prepared in Power BI together with Dynamics data and allow Azure services like Data Factory, Databricks, Synapse, ML to link to it to use the data out there. So how to position Power BI data flow as compared to other services, say like Azure Data Factory? So first of all, Power BI data flow is for business users, for data analysts, for departmental analysts. It's not for enterprise ETL solution because there's some things pay attention is not support. For example, complex transformation, let's say using Spark, for example, Spark transformation or complicated T-SQL like store procedure transformation. It does not support like multi-step preparation by using complex looping like transformation like you can do in Data Factory using pipelines, and the pipeline itself can be linked to other pipelines. It does not support large-scale orchestration like you can do in Azure Data Factory or Synapse Data Pipeline. It does not have strong or flexible processing compute engine. You cannot add compute as you can do. It does not have flexible triggering options like you have in Azure Data Factory or Synapse Data Pipeline. It does not have Git integration, for etc. I would love to do a Power BI data flow demo so that you can see what it looks like. So on Power BI services, basically when you get onto Power BI services and you are going to the workspace, you can go to the datasets and data flow tab and add new data flow. When you add a new data flow, you can basically define how you want the data flow started with. You can define new tables. You can link a table from other data flows. You can import a model. You can attach a common data model folder. So let's start with scratch. You can add new tables. So add new tables is you can do, for example, I can say let's come from a JSON file, and you can define where you want to. You can upload the file, you can link it to a file. I can even browse my OneDrive and then find the sample data through that way. I'm going to use an example in my OneDrive. I can load the volcano data I have in example as an example. And then you can next, click on next. It will load it, and then you can see a Power Query window again showed up. You can do transformation like I have showed before, the Power Query experience. And then you can save and close. Once you do save and close, I'm going to discuss this one because I already have one prepared here. Once you save the close, it will show as a data flow. And each table is a data entity. Basically, you can take a lot of actions here. You can edit table, which will send you back to the Power Query window. You can also apply AutoML for your data table, data entity. For example, you can apply the machine learning model against a prediction type columns you want, and then you can select the features. It then will generate a ML model for you for prediction purposes. You can also schedule refresh or increment of refresh on the data entity. Once you created a data flow data entity, you can go to Power BI Desktop. So for how to consume it, you can go to Power BI Desktop and get the data from, let's say, Power BI data flows, and then further you can use the pre-built data flows defined by yourself, your colleagues, use it to put it, and you can leverage the data they prepared for you or pre-prepared into Power BI datasets, and then you can create a visualization out of it. So pretty much that's the presentation, a quick demo of Power BI data flow. Let's go back to the presentation. The last services I would love to cover today is called Azure Streaming Analytics. So Streaming Analytics is a service which supports real-time data processing. But before I talk about the Streaming Analytics services, let me first ask you a question. What is real-time analytics means to you? So pretty much this question is really asking how much latencies your customer can tolerate. Data actually can be processed in batch. Batch schedule can be every day at a certain time, every month, every week, or micro batch, right? Let's say you can say let's refresh the data every 15 minutes. If the data is kept fresh every 15 minutes, your customer may think, oh, this is fresh enough. And then you can basically the fine line between batch and micro batch, or how you define micro batch, is that you need to make sure the data is processed before the next batch is coming in. So the speed and the performance of micro batch is required that way. Streaming processing is what we usually define as a sub-second data processing. Performance of data processing. There are many other services supports streaming processing, real-time streaming processing. For example, the Spark streaming engine, Spark streaming. For more code-heavy streaming process, as well as Azure Streaming Analytics, which is more T-SQL like the streaming processing. So overall, real-time analytics is a balance between requirement and the technical capabilities of the solution. More often, a lot of enterprise requires both batch and streaming processing. Thus, the Lambda architecture data processing infrastructure come into play to support such needs. So basically, when data comes in, it supports both the batch layer and the streaming layer processing of data. And finally, it can be presented at the serving layer in the independent way or combined fashion. I would love to recommend you to look at the streaming analytics if you are looking for services that supports the streaming layer of your Lambda solution. Because it is fully managed, it has declarative SQL-like query language, supports that. It's easy to get started. It can define source and sink integration on the portal, Azure portal. You can, it is fully managed. There's no need for cluster provisions. It can lower your total cost of operation. It is support enterprise grade SLA to support mission critical solutions. With streaming analytics, it supports complicated event processing. Not only start with support simple event processing like filter, enrich, split, it also supports event stream-based processing like aggregate rules. Lastly, it also support more complicated event processing like time windows, joins, correlations, pattern detection. I would do a quick demo on streaming analytics on the portal itself to show you the layout of streaming analytics on Azure portal. There's other sessions in Modern Analytics Academy series also show the streaming analytics to show you different demos. So I won't spend too much time on the today's demo. So let me go to a streaming analytics example I have here, and let me refresh it. Here we're at the Azure portal, and there is a pre-built streaming analytics job I've set is set on running. And there is on the overview panel, you can directly see there is input and output. Input for this job is IoT Hub, and the output for this job is Power BI streaming dataset. Obviously, you can add more inputs or more output in the streaming job. Basically, you can say, I need the streaming from multiple sources and join them together to form an output. You can do that also. So on the streaming query, as you can see, it's really like it's SQL like. It's declarative. Is SQL. So it's easy to edit and write author in the portal. And you can monitor the streaming job and performance, the resource utilizations, all in one place. Cool. That's the end of the demo for streaming analytics today. Again, you can refer to other sessions for more demos. So here's come to the decision criteria when you're choosing a data pipeline. I think there is many metrics you should think about in terms of speed. If you need the SSIS in migration, if it's a large-scale batch processing, enterprise scale, or self-service, or code-first or low-code transformation support. With Azure Data Factory and Synapse Analytics supports large-scale enterprise batch or micro-batch processing. It supports both low-code and no-code. The difference as I mentioned before, is that Azure Data Factory supports SSIS migration, one-to-one migration. With Power BI, data flow is more targeted for self-services purposes. It's batch load, it's low code. With streaming analytics, is for streaming speed, and is code first with T-SQL like query. If you need to find more resources, you can go back to aka.ms/maa. We not only have stored the recordings, but also the slides as well as some hands-on labs material. Thank you for watching the data pipeline session today. I hope to see you in other sessions.